Hi everybody. So this was the first of two videos that I was going to show tonight, and I'm recording this one from the classroom, so I hope it's going to work out well. Um, we'll go ahead and give it a shot, and we'll see how it goes. So I wanted to do a couple of the story problems from our practice test. The first one I'm going to do is number 27, which is the perimeter of a rectangle backyard is 44 feet. And the width is 18 less than 3 times the length. So you'll have situations like that where you're given the formula, well, not the formula, but you're given the one of the equations in which you're going to need the formula, and on the other one you just need there'll be some sort of relationship between the two. But again, as we talked about as far as story problems are concerned, you're always looking for two scenarios, and within those two scenarios you have just two variables. So in this case, length and width. So I've gone ahead and I've drawn a rectangle, and I want to just kind of walk through the formula for perimeter. Remember, the perimeter is simply the measurement of each of the four sides added together. So in other words, that's W plus L plus L. So length plus, excuse me, width plus length plus length. Another way to do that, or write that, is W plus W is 2W, and length plus length is 2 length. So again, that's going to equal my perimeter. So when I'm setting up my equations, though, I can say that x is my width, and my y variable is going to be my length. So what this problem is saying is that the perimeter of this backyard is 44 square feet. So I can say the perimeter, substituting my x's for the w's and the l's, I can say that 2x, so two of my widths plus 2 of the lengths, is going to equal 44 feet. Now, it also says that the width is, so width being x is. That's one way to say that. When you see the word is, just write equal sign. So the width is 3 times, 18 less than 3 times the length. So if length is y, that's going to be 3y minus 18. So now I have my two equations, and it's pretty much set up for substitution fairly well, because again, all of this is what equals x. So I could take all of this and substitute it in for that x right there. So I'll go ahead and do that now. I have 2 times 3y minus 18 plus 2y is going to equal 44. So I distribute the 2. So now I have 6y minus 36 plus 2y equals 44. I'm going to combine my like terms, which are the ones that have a y in it. So now I have 8y minus 36 equals 44. I'm going to add 36 to both sides. 8y equals 80. Dividing both sides by 8, I get y is equal to 10. So then I know that the length of one side of my rectangular yard is 10 feet. Okay, so having said that, let's go ahead and find the width. Again, we're going to plug it back into either one of our equations. I'm going to go ahead and use this one. So if y equals 10, so I can say 2 times x plus 2 times 10 is going to equal 44. So that gives me 2x plus 20 is equal to 44. Subtract 20 from both sides. 2x is equal to 16. X then is going to equal 8. So what this is telling us is that the width of the yard is 8 feet. The length is 10. Sorry. Correction. Sorry about that. That's actually 24. So 2x is equal to 24 means x equals 12, not 8. Okay, and so we could do a quick check. We got 10 plus 12 is 24. plus another 10, 34, plus 12. I don't know what's going on with me tonight. Let's try that again. So 10 plus 10 is 20, and 12 plus 12 is 24. 20 plus 24 is in fact 44 feet as we originally said. So again, the formula is 2x plus 2y for perimeter. The second problem, I'm going to go ahead and erase this one. The next one I'm going to do is number 29. Kind of reviewing this one real quick. It says Sutton found a large bag of coins when wandering around her neighborhood. Instead of doing the right thing and trying to find the person who owns the money, Sutton decided to keep it. She counted the bag of coins and realized that there were only quarters and nickels inside. So if you notice, we're now all the way down to the third sentence or the third line of this 5-line sentence, and we're just now getting to any information that we need. Okay? But it says, after counting all the coins, she realized that there were 150 coins in the bag. So again, counting is usually we have one of one type of coin plus one of another type is going to equal 150 total coins. So almost always with coin problems, what you're going to see is that all of one type plus all of the other is going to equal something. And all we're doing is counting. So there's no decimals, it's not a money problem yet. This first equation is simply counting how many, in this case, she found out there were only quarters and nickels. Okay? So I'm going to let x equals nickels. And y is going to equal quarters. And again, as I mentioned earlier, it doesn't matter which you use for which as long as you set up your equations properly. So just simply counting the coins all together, I have 150. But now it also says that after counting the change, she realized that she was $17.50 richer. So it asks how many quarters and nickels did she have? So nickels, as we know, are 5 cents each. So I'm going to go 0.05 times x plus 0.25. So in other words, that's 5 cents for each nickel plus 25 cents for each quarter is going to equal $17.50. Now it's a money problem. Okay? So again, I'm going to rearrange this first equation. And I'm going to isolate the y value because it's already a coefficient of a positive 1. So I'm going to subtract x from both sides. I get y equals a negative x plus 150. Now I'm going to substitute that y in for right here. So I'm going to have 0.05x plus 0.25. That was times. Times negative x plus 150. And that's going to equal $17.50. So I'm going to distribute, rewrite my terms, 0.5x. That's a 0.25 times a negative x is going to give me a negative 0.25x. 0.25 times 150 is going to give me 37.50. And all of that is equal to $17.50. I'm going to combine my like terms. I get 0.05 minus 0.25 is going to give me 0.20 or just 0.2x. Again, that's just that minus that plus 37.50 equals 17.50. So I'm going to subtract the 37.50 from both sides. 0.2x is equal to negative $20 even. X equals 100. So again, I'm going to divide both sides by 0.2 and then get X equals 100. Now that I know I have 100 nickels, I'll go ahead and write that over here. So this part actually then is pretty easy. You have X equals 100, so 100 plus Y is going to equal 150. And we really don't have to see the math that obviously, then that means that quarters has to be 50 cents each. Okay? So our ordered pair answer, if we were asked to give one, would be 100 for X and 50 for Y. Again, that tells us that we have 100 nickels and 50 quarters. Again, I just wanted to reiterate, as far as the story problems are concerned, just the key to remember is that you're looking for two scenarios that share two of the exact same scenarios, or variables, not scenarios. Two scenarios that share the exact same variables. In this case, we had nickels and quarters. We had total nickels plus total quarters equals 150 coins, and we had 5 cents plus 25 cents equals $17.50. And so again, the quarters and nickels are the two variables that are shared between the two scenarios. In our previous problem, we had length and width, which was in both formulas, the one for perimeter and also in the relationship between the two. So when you're going through the story problems, pick out the information that's important. Two scenarios that share two of the exact same variables. Thanks so much. I'll be sending the other video out here pretty soon, and that one will cover the elimination method. Thanks so much.